All right, so on 11.3, we're talking about how can we represent data graphically, right, visually. And we get back into this idea of skewed. Okay, we did this with the box whisker plot on Tuesday. So we're looking at symmetric, and this is either a bar graph or a histogram, and we'll take a look at the difference between those, what a histogram actually is. But we've got our bars here. We know what symmetric is. It's the same on both sides. And then it's just like our box and whisker. If it's going to be skewed left, skewed left, that means it's going to be stretched out to the left. That whisker was longer on the left, right? So if I were to relate this to a box and whisker plot, it would look something like that, right? It's stretched out to the left. Same thing with the skewed right. We are stretching it out to the right. Okay? We just got to know, we got to be able to identify. That's a lot of the questions today are, what type of distribution is this? Left, skewed right, symmetric. Okay, so that's part of it. And you see the explanations down here. You know, the tail extends to the left, so it's stretched out to the left here. And then it tells us most of the data is on the right, right? So ignoring this little tiny thing, because that's not a lot of data, this is a lot of data. So we're saying if we looked exactly halfway through this graph, right, most of that data is to the right. So that's what they mean by that, not that little tiny bar. They're talking about this being the majority of the data. Okay. All right, so we've got that. And then we've got this idea of a histogram. Okay, and I don't know if you've seen a histogram, if you know histograms, but we're going to talk about it here. A histogram looks like a bar graph. The difference is it uses intervals. Okay, it's a range of values. It's not just one value. If it's a true bar graph, we would have one bar for one ticket sold, one bar for two tickets sold, and 3 and 4. But you can imagine if we're selling all the way up to 56 tickets, that's a lot of bars. We're not going to draw 56 bars on a graph, right? Nobody wants to do that. So instead, we group them together. And that's what makes this a histogram. A histogram is with intervals. So you see the intervals are always going to be the same number of values in there. 1 to 8, 9 to 16, 17 to 24, right? It's evenly spaced out here. But what that allows us to do is kind of clump those values together. And instead of making 56 little bars, we can make 7 bars, which is a whole lot better. And we can still tell a lot of things from this, right? What type of distribution would you say this is? Type of distribution, yeah. Say it again? Yeah, I'd say it's symmetric. It's pretty close, right? Pretty even. The biggest one's in the middle, right? We can't be too concerned that this one's slightly higher than this one. The middle is the biggest, and then it kind of goes out from there. So we would say this is about symmetrical. Okay. And then we can see in a histogram here, it talks about frequency. So this is how many times do we have numbers that are in this range. So if we're collecting this data, right, number of tickets sold, and I think it's raffle tickets sold by students, right? If we ask you how many students sold between 1 and 8 tickets, well, it's right there, right? We can see that bar. There are 5 people that sold that. So it's not that they sold 5 tickets, it's that 5 people sold in this range. Okay? You are not going to be asked to create histograms at all. Well, let me rephrase that. You're not going to be asked to create the intervals at all, the numbers. The numbers will be there for you. You're going to see it on big ideas, and it's going to be kind of a cool thing where you click on it and you drag it up as far as it needs to go. Okay, so you're going to be creating the bars to go where they need to go. Sometimes they're going to give you the frequency, right? They're going to give you they're going to give you this chart to go with it. And they're going to have that graph created with those intervals. And you're just going to have to drag it up to 5, drag it up to 9, drag it up to 16, and so on. There are other times where they're going to give you that interval, but then they're going to give you something like this. And you're going to have to come up with that frequency. Okay, so if they give us an interval, let's say the first interval is that they give you is 31 to 35, then you need to go through and you need to count how many values we have between 31 and 35. Okay, and then it would be 36 to whatever, 40 over here. All right, and you would just have to count up however many there are, get that number, and that's how high that bar would go. So that's the sort of thing you're looking at with a histogram. Any questions on what a histogram is, what it looks like? All right. So beyond just creating it and what type of distribution we have, you're going to be asked a lot of questions about this stuff. So you're going to want something down in your notes about it, okay, about choosing the appropriate measures. What is the best way to describe data based on what type of distribution we have? Okay, so I wouldn't write it word for word, but I would definitely have, all right, this is symmetric. I'm using the mean, I'm using standard deviation. I would have that stuff down, right? Have the main points down in your notes about it. Because like I said, you will be seeing this a lot on the homework tonight. So when it is symmetric, and we see the picture, when it is symmetric, we're going to use the mean to describe the set. Okay, if you have symmetrical data, the mean is going to be the best representation of the average, quote unquote, average of your data. And then standard deviation is going to be best to describe the variation. Okay, anytime that it's symmetric. But that's not all the time, right? It's not always symmetric. Sometimes it's skewed. We have, you know, that tail off to the left or the right, bless you. And we have to describe it still. So when we see these graphs down at the bottom here, if it's skewed, we're not going to use the mean anymore. We're not going to use the mean because the mean is being pulled off to the side a little bit. It's not the best representation. The median is going to be a better representation because that's going to tell you in the middle of that data, right? There's the same number bigger as smaller. So we're going to use the median whenever it's skewed. That mean is just going to be pulled off to the side. We don't want to use something that's not a good representation. And then also when it's skewed, we're going to use that 5-number summary. Remember that 5-number summary was our box and whisker plot. And specifically the 5 numbers that we use to create it. So when it's skewed, we're using the median and the 5-number summary. Okay, you just got to remember those things. If it's symmetric, mean, and standard deviation. If it's skewed, it's median, 5-number summary. Appreciate all of you guys writing stuff down, taking notes. That's good stuff. Hopefully we're starting to get to the point by now that I shouldn't have to tell you, hey, this is important, let's write it down, but you're starting to pick up on, hey, I should probably write this down. That's the goal. Once you get into high school, once you get into college, for sure, they're not going to stop and say, I think you should write this down. They're just going to talk. And you're just going to have to try to keep up. Okay? So it's a good habit to have, being able to write stuff down that you find important. Anyway, moving in. I digress. All right, so kind of the last idea that we have here. It's gonna take us a little bit of time to get through this. But the idea here, you see here, it says many real life data sets have distributions that are what we call bell shaped. Okay, this is a bell curve or a bell shape. We're going to see it here. And this is a lot of statistics. I took a few statistics courses in college and we follow the bell curve and we follow this a lot. And you'll get into it in high school as well when you get into stats course. This is just an introduction into that. We're not going to use it a lot. There's like one specific type of question that I'm going to point out that we're going to see this on. But I want you aware of it. And we've got this bell curve, and we said if it's symmetrical, and that's what we're talking about, is a symmetrical graph. That mean is in the middle, and that's that X bar, right? That's the mean. That's the middle. If it's symmetrical. What did this symbol represent? That symbol. What did that represent? Dave? Yeah, that was standard deviation. That was standard deviation. So what we're saying here is if you take that mean, and we figured out how to find standard deviation. If you take one standard deviation in either direction, okay, the mean plus or minus one standard deviation, 68% of your data is going to fall there in this bell curve. 68% of your data is going to be within one standard deviation of both sides. If you go two standard deviations on either side, okay, plus or minus two standard deviations, that's going to include 95% of your data is within two standard deviations of the mean. And that's the great majority of your data, right? And there's so many times in real life where you follow this bell curve. All of your data falls into this, okay? And we see 95% within those two standard deviations in either direction. What we can do with this is we're going to answer one specific type of question. And it's going to look like this, and you're going to see it on the quiz. And they're going to give you a whole lot of information about two different data sets here. So take a look at what they're showing us. We're seeing the results of a survey. As men and women, how many pairs of shoes they own. So they give us a lot of information. Survey size, that's just how many people they surveyed, right? It's how many people did they ask? 35 men, 40 women. The minimum, maximum, that's the smallest and the biggest number of shoes. Q1, median, Q3. So here's your 5-number summary. Right? You got your 5-number summary there. You got your mean, which is the average. And then you got your standard deviation. 24 pairs of shoes, that's a lot of shoes. That's a lot of shoes. Are you saying you have more than that?
No, my mom does.
Your mom does, okay.
She has
All right.
a whole closet full of shoes.
Well, that's a good thing I didn't ask her
Our
then.
closet is bigger than my bedroom.
Wow. Wow. Oh, when you got that many shoes, you need a big closet. And only 2 pairs of shoes, that seems very low to me. Like, yeah, sneakers, but I mean, what if you're going someplace nice, right? You're going to church, you're going to a wedding. You gotta have another pair of shoes. You gotta have probably some sandals. You gotta have cleats if you're playing sport. Anyway, seems very low to me, but regardless. And I have never met a woman that only had 5 pairs of shoes. That seems very low. Maybe it's just me. I don't know. Anyway, so the things that they're going to ask you, and I'm telling you right now, the ones in the homework are going to match up just like this. The one on the test quiz is going to look just like this. Same information, different numbers, but same information, same types of questions. First one says make a double box and whisker. That's already going to be provided for you. you're just gonna have to describe the shape. Okay, they have that here. We can describe the shape. That's what we've done already with 11.2. Right? Tell the person next to you, how would you describe the shape for the women and the men?
Yeah, I don't know. Yeah.
All right, so what type of distribution do we have? What would we say? How would we describe the one for the women? Levi? Yeah, I'd say that's symmetrical. That's pretty close, right? Even though it's a little smaller here than here, overall pretty symmetrical. How about for the men? How would we describe that? Right? Yeah, it's skewed right. Right? This is bigger than this. This whisker is bigger, right? This is kind of stretched that way. So it's stretched to the right, it's skewed to the right. So that's what we would do for that first question. The next question says, compare the number of pairs of shoes owned by the men to the number of pairs of shoes owned by the women. This is just in general. What can we say? In general, what can we say about number of shoes according to this survey? Eli? There you go, right? That's what we can say in general. Whether it's right or not, according to the survey, that's what it says. Okay. And then the third question, this is where our bell curve and our standard deviations and everything come in. Is this third question. Okay, the third question says about how many of the women surveyed would you expect to own between 10 and 18 pairs of shoes? So here's what we do. We take a look at 10 and 18. These numbers are always going to be, if you take the average of those numbers, you go in the middle of those numbers, it's going to give you the mean. Okay, that's how that's always going to be. They're going to tell you something around the mean. Our mean is 14 for women. And remember, we said in our bell curve, let's draw it in here. We got our bell curve, we got our mean in the middle. And then we said if we go one standard deviation away, that was 68% of the data. So if you look at 10 and 18, 10 and 18, 10 to 18, and our standard deviation is 4, that's one standard deviation away in both directions. So since that's one standard deviation away in both directions, our answer to this would be 68%. Your answer to this question is always either going to be 68 or it's going to be 95. It's either 68 or 95. That's it. Those are your only two options for that type of question. But you have to remember those numbers. Okay, you give me 67, it's wrong. 68, 95. 68 is when it's one standard deviation away on either side. 95 would be when it would be two standard deviations away. So that would be like if we asked the question, how many would we expect to have between 6 and 22? Because now 6 and 22, to get to 22, I'm doing 2 standard deviations away. To get to 6, I'm doing 2 standard deviations away. So now I'm going 2 standard deviations in either direction. That would be 95%. Yeah. Yeah, because we're doing the very basics, right? It's always either going to be 1 or 2 standard deviations. Yep. Obviously, once you get into stats and there'll be more and more difficult questions, but for us, we're keeping it basic. It's either going to be 1 or 2 standard deviations. Okay, I want you to recap that with somebody. How can I answer this type of question? How can I answer that type of question? All right. Here we go. Any questions on that? Any questions on our standard deviation use here, our bell curve? Okay, good. I expect us to get that question right now. All right, any questions on what we've talked about today? We talked about this distribution, the skewed left, skewed right, and symmetric. We talked about what types of measures we're going to use when we see that, right? Whether it's mean or median that we're going to use, whether it's standard deviation or a 5-number summary. We talked about bell curve, standard deviations. I think we're okay. Any questions about it? All right, you guys are